Evening all, it's Ryan here from RLF Vacuum Cleaners in Lakenheath, and today I thought I'd make a quick video, just a quick video, as we are finishing off a load of our refurbished TruVox machines. And one of the people asked, or one of the questions I was asked was, how do we test the cables? So I thought I'd go through a quick how we test cables on these machines. This is the setup we use to test cables. We use our Clare A252 portable appliance tester, and we use our quicktest quick connector block cable, and this is the little adapter that I made up so we can do these particular cables because they have a funny plug on the end, a 2-pin kettle lead plug. And all we're going to do is grab one of these cables here. So here we are, one cable come in. This cable has been washed. What we do is we use warm water, mild soapy solution, a bit of Scotch-Brite, and it brings the cables, it takes the worst of the dirt off. I'll show you a pre-washed cable. I'm not quite sure how well the camera will show it, but this is a washed cable. You can see it looks reasonably okay. This is a unwashed cable, and you can see it's got like these sort of brown marks, scuffy marks on them. When we wash them, it serves two purposes. Number one, as we are washing them, we fully unwind the cable, and as we're cleaning it, you can check for any small nicks, damaged insulation, basically any damage that might cause a problem. Secondly, it just makes the cable look a lot better. You know, you send a refurbished machine out, everything's, you know, fully clean, and last thing you want is a fully clean machine to have a cable dirty. It doesn't give a good impression. So that's two reasons why we wash them. We leave them to stand a couple of days, 2 or 3 days, make sure they're sort of fully dry, especially this time of year. We usually put them in front of the heater for a day, or if we're running the heater, we put them near the heater so they warm up and dry out, so when we come around to test them, they should be alright. Just pulled up a couple of examples here of why we test these cables. As you can see, I'm not quite sure how well the camera's going to focus. Oh, there we are. Going to focus. But on this particular plug, you see that the cable strands have started to fray. That's better. Cable strands have started to fray and overheat. This causes poor connection. Obviously, poor connection means the machine's not going to work. So we receive machines from all over the country, rental machines, X machines, and people just abuse them. And of course, once you had one or two, when you refurbish a machine and you send one or two out with a dodgy cable, of course it works in the workshop, but when it's out on the customer's site, they're moaning intermittent use, cable only works when the cable is in one position. This is quite an extreme example, because when we stripped it down, literally we could gently pull, and they snapped off. And it's literally just as they come out of this cable right here. It's always a pain in the ass. Cables always break just as they come out of the stress relief. That's the plug end, but we also had it on the other end with this line or live wire, as you can see. Get that in the light, get that focused. As you can see, that's completely melted through, but of course it's intermittent because it'll touch and it won't touch, and it sparks and it gets warm. And as you can see, this is the outer sleeving. It's always after the strain relief. As you can see on the cable, you can see that's got quite hot and melted through, but the actual outer cable, not a mark on it, which is, you know, one of the annoying things. You know, you can visually inspect your cable really good, but you know, you got that on the inside, which is always after the stress relief. So that's why we test them, and we use our Clare machine. I'll go through the testing procedure, and it will show what we pick out or look for. Right, the first test we do after we wash them is, first of all, we check to make sure that there's no water stuck in the plug, which can cause an earth fault. So first of all we do is do a 500 volt insulation test. On this particular machine, it's the bottom scale. As you can see, it's on infinite or infinity resistance, which means it's higher than the machine can read. And we turn the test on, and it moves, well, barely moves. So we've got a very good insulation resistance between earths. That means there's no water in the plug. Sometimes, depends who's washing them, they can be a bit, you know, hand-fisted, and they can get the plugs, well, depends how well the plug's been made, but also helps who washes them. When I tend to wash them, I tend to keep the plug ends out of the water and try and keep them dry as possible. But some people don't, they usually splash water everywhere. And if the plug's not too good, you can actually get water on the inside. So when you do a 500 volt test, water conducts between the two pins. They should be fully sealed. Moulded plug, they should be fully sealed. That shouldn't happen, but I have had it happen a couple of times. So we always do a quick 500 volt test, make sure everything's good. This one is. So then we go on to, this machine does a high current earth test. And what we basically do is, this machine's wired up so it works on the earth pins. And what we do is we use our quick test here and our cable, and we basically swap it over. So basically we put 20 amps down the line and the neutral wire, and using a bit of mathematics, I've done this already because I do this all the time, but we work out that the cable resistance, the length of it, should be around the 0.3, but because we keep the fuse in, the fuse is around 0.05, so obviously round about the 0.3 mark. We generally tend to find if any cable is over 0.4, we just bin it. Generally, you know, it's on the way out, and of course we get infinite resistance. That means it's either buggered or it's blown open. Usually what happens is, if you get a dodgy cable, it'll start at 0.3 and it'll just keep going until eventually it'll just keep going basically. If you've got a dodgy one, we usually do the test for about 5 seconds. Usually it goes up to 0.3, and you can see if it starts increasing, it goes past 0.4. You know, just end the test straight away. It's a buggered cable. At the end of the day, I'd rather fit a new cable than have a customer ring up and say, we've got a faulty machine, can you send us a new one? Because generally speaking, a cable is generally cheaper to put a new cable on than it is to send a new machine out and get the old one back again and repair it. So if in doubt, slap a new cable on. So first of all, what we're going to do is we're going to unplug this from here. Grab my little adapter. This is just a connector off a machine I scrapped. So you plug that in there like that. Because we do all this all the time, the top one, the top connector, is your live. So you put that in the connector block, like so. Try and do this one-handed, always a tricky bit. Ooh. So you've got that in there, so you put your live wire in there, shut the lid, makes everything nice and safe. And this is the bit. So what we do is we just put the clip on the live pin like so. Yes, I have indeed paused it up. I forgot to plug in the connector block, so we'll plug that in. Press to test. Hang on a minute, I must have. And we press the test. As you can see, ooh, we've gone past 0.4, and that's on the live. So we'll just repeat the test on the neutral, see if that one's any different. Generally speaking, usually one wire's dodgy, usually the other side's not far behind. So we got it connected up onto the neutral side this time, and we'll see what reading we'll get off it. Again, it's over 0.4, so as you can see it is slowly climbing. So yeah, I'm going to say that's a dodgy cable, and we'll scrap that. Always when you're scrapping old cables like we do, what we usually do is we usually build up a pile of them and scrap them once a year when we know that the copper price is good. Always take the fuse out. Always, always, always. Especially if the cable is damaged. This one wasn't too bad, it wasn't damaged, but always take the fuse out. Especially if the cable's damaged. Because you never know, somebody could come along, plug it in accidentally, and you know, I know it probably wouldn't happen, but it probably could happen, and for the sake of, you know, 10 seconds, popping the fuse out makes it a hell of a lot safer. Plus, if you come across a cable with no fuse, you know it's dodgy. So that's always a good thing. No fuse, cable dodgy. And we just took the fuse out. The problem is, when you do so many of these blooming machines, you end up with piles and piles and piles of 13 amp fuses. So if anyone's interested in bag loads of 13 amp fuses, let me know. You can have some. But the problem is, I've never come across anybody who wants bag loads of 13 amp fuses. One or two maybe. Use one or two maybe for fault finding, but very rarely. You very rarely get fuses go nowadays. So what we've done now is, we've got another cable. We're just going to connect this up like so and test it. So we'll put that connector on like that. Problem is, trying to do all this one-handed, a bit fiddly. So anyway, I'll connect it up. This side we're going to start with the neutral, because that's what side we were on. We were using it yesterday on the last cable we were doing. As you can see, neutral just over 0.3. So I'd say that was a good time. You factored in the resistance to the wires, the resistance of this, you're going to be over 0.3, so I say that's alright. I'll swap that over there. Take that one out there. Making a new testers are pretty random really. And then we've got this one, which is live with the fuse in under 0.4. So the time you factored in, you know, your 0.05 for your fuse and your resistance, not that far out actually. As you can see, I had it on for a good several seconds, it's holding steady, so I'd say that's a pass. And then we'll put that onto our machine. That's the cable on the machine, all nice and done. That's the end of this video, so please like, comment and subscribe.